Have you ever looked at a massive chemical plant with all its tangled pipes and giant tanks and just wondered, how on earth does that get designed? How do you take a complex idea and put it on paper so that everyone, from the engineers to the builders, is on the same page? Well, that's exactly what we're diving into today, the essential blueprints of chemical engineering.
So here's our game plan. We'll start with why these diagrams are so critical in the first place. Then we'll look at the big picture view, that's the block flow diagram or BFD. After that, we're going to zoom in on the details with the process flow diagram or PFD. We'll put them head to head to really see the difference, and then we'll wrap it all up by looking at how they work together to turn a cool concept into a concrete reality.
All right, so before we jump into the how, let's talk about the why. I mean, in a field this complex, why are a few simple drawings so unbelievably important?
Think about it. Imagine trying to explain how to make, say, methanol, just using words. It would be a nightmare, right? A novel-length email of confusion. That's the huge challenge engineers are up against. How do you communicate this incredibly complex dance of chemistry and machinery clearly and concisely?
And that's the answer. These diagrams are that language. They're a universal way for everyone involved, designers, managers, operators, to see the same vision, to speak the same language, and to build the same thing.
So if we need a map for our process, where do we start? Well, you start with a bird's eye view, a high-level sketch of the main route. In engineering, that's called the block flow diagram. The block flow diagram, or BFD, is your 30,000-foot view. It is intentionally simple. You see those blocks? They don't represent one specific machine. Nope, they represent a whole stage, like reaction or purification. And you know what? That simplicity is its superpower. It lets you brainstorm the big ideas without getting lost in the weeds right away.
And here is a perfect example. This is a BFD for making methanol. See how clean that is? It just flows, left to right. You start with feedstock preparation, move to syngas production, then methanol synthesis, and so on. The entire complicated process is boiled down into a simple 5-step story. So the whole point of a BFD is to use it at the very beginning of a project. Its job is to get the main concept down and identify the major stages. Because it's so simple, you can sketch out a few different ways to get from A to B and see which route makes the most sense before you commit to anything more detailed.
And there are just a few simple rules to make sure it works. The flow always goes one way, usually left to right. Remember, blocks are stages, not equipment. You got to keep it clean, use arrows to show where things are going, and label your main inputs and outputs. A good BFD should let anyone understand the process at a glance. No report needed.
Okay, so once that big picture concept is locked in with the BFD, it's time to pull out the magnifying glass and add some detail. And this brings us to the process flow diagram.
The process flow diagram, or PFD, is the next level up. Now, instead of those abstract blocks, we start to see symbols for the actual major pieces of equipment that are going to be used in the plant, and we see exactly how they're all connected.
Now, take a look at this. See the difference? We've got symbols for a compressor, a reformer, a reactor, a cooler, the whole shebang. This isn't just a concept anymore. This is starting to look like a real, buildable process.
Yeah, on a PFD, you're going to find all the key players. We're talking reactors, where the magic happens, compressors to ramp up the pressure, heat exchangers to control the temperature, and things like distillation columns for purification. It's basically the cast of characters for our industrial play.
All right, so we have our high-level map and our more detailed street view. Let's put them side by side to really hammer home the key differences between them.
This table sums it up perfectly. Your BFD uses simple blocks for big stages. The PFD uses specific symbols for equipment. The BFD is low detail, just a quick overview. The PFD is medium detail, it actually shows you how things are connected. And most importantly, their purposes are different. The BFD is for dreaming up the concept, while the PFD is for analyzing the operations and starting to design the real thing.
Now for the most important part. Let's connect the dots and see how these two diagrams work together to bring a design from a sketch into the real world.
This slide shows the entire workflow in one beautiful shot. The PFD on the right literally grows out of the BFD on the left. You can see how that one block, methanol synthesis, just explodes into a whole system of specific equipment. A reactor, a cooler, a separator. Each concept block becomes a set of things you can actually go out and build.
And this quote nails it. This is a logical progression. You absolutely have to establish the basic path before you can start picking out the specific machinery. You start with the BFD, then you expand it into a PFD. It has to be in that order.
Now, for anyone learning to do this, here are a few common traps to avoid. The number one mistake? Putting way too much detail into the BFD. Remember, its power is its simplicity. Other big no-nos are forgetting to label stuff, which makes it useless, or just drawing equipment all over the place without a clear flow. You have to understand the sequence first.
So there you have it. The two fundamental blueprints that turn a chemical concept into a physical reality. The BFD gives you the map, and the PFD shows you the roads and the landmarks. So the only question left is, now that you have the tools, what amazing process would you design first?